Welcome back and welcome to ENG-002, which is our engine block right-hand part. I hope you have all enjoyed the programming thus far in your first couple parts. I'd like to remind you that they're always the most difficult as you work through the ins and outs of MasterCAM. As I'm sure you are all realizing, there's lots of hiccups that can be made, and really it just gets better as you get more experience in MasterCAM to getting by these hiccups. Now, do I have, I guess to say, sort of a gift for you? I want you to look at this part, ENG-002. If you're this far in the curriculum, you should have already made ENG-001. Let's take a look at this. If I can inspect this part from side to side, 0.938. If I inspect this part, 0.938. The height will be the same. I know that because I could see in my assembly, my left hand and my right hand are the exact same size. They are mere parts. In reality, if we take a look, I can isolate them. Take a look on the inside. Everything, lots of things are the exact same. The 10-32 tapped holes on the top. So our op1 should be the same. There's a little bit of extra stuff on this inside of this part, which we'll get to, obviously. There is a counter bore on this back side of this part. And instead of having tapped holes, we have a through hole for our bolt. We have a through hole for the crankshaft and the crank bushing that go into here, which we didn't have on the other side. So there is some extra stuff, but in reality, a lot of the stuff is the exact same. So when we have parts that are so similar, we've already done a lot of the work in our first program. So why don't we use our ENG-001 program as a starting point for 002. This will save us lots of time. We don't have to change a lot of the parameters. We'll just have to import the new model and update all of our toolpaths to the new solid. So to do so, let me first get my model. So first thing I'm going to do is I'm going to export my part as a step file. I'm not sure if I have already done so. I'm trying to think if I made any changes at all. No, I haven't. So it should be there. Okay. So if I go to my MasterCAM, what I'm going to do first, I'm going to open up my program right here, ENG-001. It's in my recent files. If you don't see this, you can go to your computer and find the file. I'm going to open up ENG-001 to bring up my old part. And we'll take this slow, because sometimes when you delete your solid and import a new solid, things can get a little bit messy. So stick with me through this, but it's worth it in the end. One thing before we start, we decided in our program to actually, instead of using a 3/8 end mill, we were using a 1/2 inch end mill. Now, we'll see, we might change that later on. Actually, since we have that little hole in the middle, we might want to switch to a 3/8 depending on the size of how big, not the hole, but the boss sticking out on the side. So let's just start by importing a new part. Remember that we want to file merge. Now, before I do anything, actually, the first thing I want to do is say save as. And when I say save as, I'm going to go and make a new folder called ENG-002. Open that, and we'll save it as ENG-002 engine block, and we'll change this to right hand. That way we don't save over our last part. That's a lot I want to do. Now let's go File, Merge, and let's open up our part that we're looking for, which is going to be ENG-002 right hand. I'll say open. And this won't open perfectly, and that is fine. I just hit OK. There were some options there that you could have done a dynamic move. So you could have done what I'm about to do in that menu. But this part obviously sits against this part. But in reality, what we want to do, because a lot of the toolpaths are the same, is we want to make this part align exactly with this part. And that will make a lot of the toolpaths pretty easy. So whenever you want to bring a feature, an edge of one feature, or a corner of one feature to another feature, one of the best things you could use is dynamic translate. Translate itself, you can grab one feature and tell it to move one way, but you don't really have the option to move it to something else. So dynamic, you can take the model you want to move. In this case, it's this one. So I'm going to click on my new model that I just brought in, making sure it's highlighted yellow, and I'll end my selection. It gives me an X, Y, Z datum, which I want to put somewhere on this part that I know that I'll be able to also reference on the other part. So this part here, I mean, they're almost the exact same. Doesn't really matter what corner I grab, as long as I grab this corner and I bring it to that corner in the end. So I'm going to click on this bottom left corner. And after you've chosen your axes, that is good. What we'll do now is we want to rotate our part to get it lined up. So for me, that is, it looks like -90. So I'm going to type -90, press enter twice. Now that I'm in the exact same orientation, and exact same being very important, I could just grab the little sphere in the middle and I can move it up to the corner here and it should lock into place. We should see that we have a lot of overlapping features by the shimmering between the purple and the gray. That is good. That's what we want. Obviously, the holes are going to be different, and it looks like our pocket is slightly different in depth. So we'll have to make sure that we update that pocket to that new depth. I will hit OK. Everything looks good. And the next thing I'm going to do is I'm going to decide what I want to delete. And that being key, decide what I want to delete is a key thing. Obviously, I'm going to want to get rid of the solid. Okay, so when I open this new part, luckily it did open up my own brand new. It opened up a brand new level for me. So let's actually let's name this ENG-002. I'm not sure why it was named wrong. Or you can call this your part if you'd like. This is my original one, so let's just turn off my new one. This is my original part. We know that we're going to want to get rid of this solid. There's nothing off of this solid that we want. When you delete, make sure it's the only thing you're grabbing, and you're just going to say yes. What I did is I grabbed my part, so I clicked on it, and I pressed delete on my keyboard. You could also right-click and say delete, and just say yes, delete all selected entities. Now, if you go to your toolpath tree, your toolpaths are not happy with you. Every one of those toolpaths, because we referenced a lot of our stock edges, they're mad. The only ones that aren't really mad is your facing, because those were referring to our stock model, which, guys, to be honest, we shouldn't have to make a stock today because our part is already located perfectly in our stock. And guess what? So we're already 20 thou below because we lined up our part in the exact same place, and it happened to be the exact same size. That's why we're able to do this. So we don't have to make stock. That means we don't have to make a stock model. Our facing one will work out, which means we don't have to make a stock model one. A lot of this stuff is done. The part's the same height, so that should mean that all my planes, my G54, I'm going to go to view, and I'm going to turn on my nom so it stays on when I click away. So my G54 is still XY corner of the stock, 20 thou below my surface. Looks good. My G55, if I hit the red equal sign, I could take a look at that. My Z0 is still the top of my part, and it is still the left side and the back side of my part. And my G56 is this side here, same as back and left. Now we will have to make one last plane, and we'll do that when we get there. But everything looks really good right off the bat. So the facing, because the facing we selected our stock level. Get out of here. We selected our stock level and selected the faces of our stock. So we didn't delete this out. We don't want to delete this out. So the facing, we don't have to update. The facing is great. The facing does exactly what we want it to do. We're going to follow the same order. We're going to do op1 from the top side. We're going to flip it around and we're going to face it from the back side. Now, our stock model, if we double check, if we turn off our stock model should also be updated to be after op the face one, or the facing in op1. That looks really good. What I might want to do is right click and say clear colors, just to get rid of that purple. And we should be good to go. Now, right off the bat, again, there's some new stuff to be done. But for this dynamic OptiRough, for each of these toolpaths now, we got to think about when we did this last time in engine 1 part, ENG-001, what did we select, right? What did we select and why? Obviously, the red X's mean whatever we used to select, meaning the geometry of our toolpath, has been deleted. A lot of what we've done is selected solid edges off of our engine 1 part to then be used to make our toolpaths. Now that we've deleted out our engine 1 part, so has all of the reference geometry that every one of our 2D and 3D toolpaths has used, because the 3D toolpath also used our part to figure out where it had to be machined. So in each one, we shouldn't have to go in and change all the individual parameters. So hopefully your engine 1 parameters were good. If you get some feedback from engine 1 saying that you made some mistakes, then you should apply that and fix it before you do this part. Notice how my machining regions, or my machining entities, is 0 because I deleted out the part. All I should have to do is triple click on my part to reselect it. Notice that my patch, by the way, guys, if you ever want to hide this menu to go and turn off your levels, a pretty cool little trick is to hit this hide dialog box. That will turn that off. Notice that whenever you're done, you could press exit and go back to it. This lets me go over here and turn on my patch. Now my patch is still there. My patch necessarily isn't fully patching this anymore because of the fact that it is a bigger pocket now. But to be honest, that is such a little gap. As long as it's smaller than half an inch, my half-inch tool, which is doing my OptiRough, should not fit into there. So for now, we'll leave it as is, but if we have to, we'll just add another little patch in that pocket there. But I don't think that will be necessary. So I'm just going to escape to go back here. Remember that all my toolpaths are already set. My 3/8 end mill. I will say that we might want to change this to our 1/2 inch end mill for this week. We might still use a 3/8 end mill, but let's add a 10th tool into here. So I'm going to select my tool. I'm going to choose a 1/2 inch end mill. If you couldn't find the end mills, if they weren't right off the bat, make sure to go filter, select your end mills. And I'm going to select my 1/2 inch end mill, and I'm going to run that at 12,000. And yeah, about 200 is a good speed. Actually, let's do 15,000, and 200 will be a good speed. And we'll select, where did my 1/2 inch end mill go? I thought I selected it. Let's try it one more time. Right here. Change this to tool number 10. Okay, I like that. My steep and shallow should be great. My cut parameters. My step down, I'd actually like to change to 0.75. I noticed that was an issue in our engine 1 part, that we only had about an inch or 0.75 of flutes. Let's just change the step down to 0.75. Other than that, everything else should be good, guys. Everything else is just copied from the last time we did this, and it should work out for us. Look at that, beautiful. We did no work there, easy. Let's go down the line. So just as with our OptiRough, we can just go into our contour and just do a little work to fix it up. just like with our OptiRough, we can just simply adjust a couple things. Now, before I get into the fixing the geometry, let's just first change this to a 1/2 inch end mill before we forget. Setting this to a good speed, 12,000, and yeah, about 1,000 is a good speed. I just want to change that over to my 1/2 inch end mill as well. I'm gonna hit OK, but it's still not gonna work. I'm getting an alarm because I haven't updated my geometry yet. So what I should be able to do is just go into my geometry. As you can see, geometry says 0 chains. So if we just click on that, all we have to do is update it. Everything else is the same. We don't have to worry about our step downs, our stock to leave on walls, our speeds or feeds, because everything is the same. So what you just have to do is press right click and say rechain all. And all we're going to do is select the bottom edge. Now, last time our tool was entering and exiting about the midpoint of this line. Let's try to position this a bit more strategic so that if you notice, there was a little mark left over from our entry and our exit point. If we can hide it, we should try to hide it. So if I click on the first half of this line right here and I hold shift, that should go around my part, which doesn't look like it went all the way around. So I'll just finish it off by clicking the red or just extending my branch over. That will make it so that my tool enters and exits at this corner. I will have to update one last thing where I go into my parameter and I should just have to go to my lead in and lead out and turn off enter exit at midpoint in closed contours. That will allow my tool to enter at that corner. If we do a back plot of this, we actually should be able to see that our tool enters exactly at that corner, comes around and exits at that corner. That will leave the mark at this corner, but since it's a 9-degree angle already, it should be hidden. We shouldn't see that mark. It should be a better looking part. Moving on, let me just open up the rest of my tool paths here. Moving on, we can see that we still have to update our holes. So it still thinks that there's some geometries, but everything's the exact same. 3/8 spot drill, tap. If we look at our parts, our engine 1 part had 1032 tapped holes down to 3/8 of an inch. If you weren't sure of that, you can go and double check the last drawing. But we could also see in our model, if we want to measure, that they do go to the same depth and they are the exact same hole. So all we have to do is update the geometry, nothing else. So first, let's just delete out the old geometries. It looks like it's trying to think that there was something. It looks like it would still sort of work, but let's just get these out of here. Just shift click to both of them and let's reselect them as this hole right here and this hole right here. It wouldn't have mattered if you selected the hole or the top edge. It works no matter what. And hit OK. Now, let's just go down to, before we update all of our toolpaths, let's just go down to our geometry here. And let's delete these ones as well on our drill. And we might be able just to say copy previous points. This little back arrow with the symbol here takes into account what you selected last time and just reselects it. So a little bit faster. Again, go to our tapped hole. Let's delete these guys out and let's just say copy previous points and hit OK. Now let's select the 3 of these toolpaths and just say regenerate all selected toolpaths. Looks like it worked. Oh, we do have an issue though, from what I see. We are breaking into this counterbore here. Interesting. Okay. So what we'll have to do is we have to be a bit more mindful of this. Our drill can't go that deep. So we're going to have to work with a little bit less clearance at the bottom of our drilled hole or our tapped hole. Remember how we added that so that we'd have more clearance? We got to cut it closer. So let's go to our linking parameters. Our depth right now is 0.5. Our tap goes to negative 0.375. I'm guessing we could double check that. Minus 0.425 because it goes a little bit past it for the breakthrough, right? To make sure we get enough threads. So we want to keep going there. So let's just make sure our drill goes past 0.425 and we should be all set. As long as it, let's go for 5. We wanted to go a little bit deeper. Like that's, we can see what that would look like. How much room is that? I can kind of analyze between here. I wonder if I could just select on the inside this hole. I could see in my Z, I have 0.1 of an inch. So anything past that, we're cutting pretty close. Anything too thin, and we might actually weaken the structural integrity of this part. It is just a counter bore. So how about let's back off. So our tap goes down that deep, our drill goes that deep. So we're probably leaving about 50 thou. Let's brack our tap off about 50 thou. So let's go to 3. Ooh. I don't want to go too much more than that because we won't get full threads. That's what the drawing calls out for. Now in this scenario, guys, you might want to reach out to your person that ordered these parts and say, hey man, like for me to get 3/8 of tapped hole, I have to break through a little bit deeper. And then I'm starting to break into your counter bore. So is there any way that we can, get away with a little bit less threads, which would let me back it off a little bit? For the purpose of this part, I can tell you that we don't need strength like this. We don't need that much strength. So even if we are left with 50 thou of material, I'm going to back it off another 25 thou. So let's say we're left with 75 thou material. We should be good in the end. It's not a lot to work with. We might take another look in the lab just to double check our tools, but in the end, we're left with a little bit of a gap at the bottom, which should be enough for our purposes, but we will want to double check this as we go to machine. All right, that's it, guys. Op 1 is done. We can move on. That's done. Nice and easy. We should just be able to click on our stock for Op 2 and just say regenerate selected operations to regenerate this solid. By the way, guys, if you do see regenerate all dirty operations, it might sort of regenerate things here for you. But we're going to do it a proper way where we come in and update all the geometry for us. So if you do that, it might show you non-red X's, but you should still go and follow by updating them all. So my op1 stock or my op2 stock looks good. I'll tell you guys this, guess what? My op2 is the exact same. Flip it over. And then we can just update this. We don't have to change that face. It's done. Beautiful. We don't have to do op2. It's done. Face is done. This is what our stock model is looking like now. Exactly what it's supposed to be. Again, we can see our plane is exactly where it's supposed to be for op3. So all we have to do is go back in and update some stuff. Now, this is going to be a little bit different because we have in the inside here, we have this little boss. So we can measure right off the bat to see how much we're working with here. We could measure from here maybe to this edge I'd like. And then it says, okay, we have 0.3435 to work with here, which is not ideal. That means we're going to have to use a 1/4 inch end mill. This pocket looks deeper than I'd like for a 1/4 inch end mill. 0.75, right between here and here. 0.7. I mean, the 1/4 inch end mill could do it, but it might rub up against this wall, which I don't love. I'd rather use a bigger tool. Now let's go take a look at this part. Let's go see what this is. I need to change this part on you guys. This external diameter, to me, looks like it doesn't matter. This diameter looks like it doesn't matter. My question is, if I wouldn't want it to be any smaller than this or else it might look weird, but if I made this smaller, say, I can inspect this, figure out what's the diameter of this. Diameter is 0.4594. Don't worry about what I'm doing right now, guys. So that's if it was the same side. How much is the difference if I'm just going to draw a line in Fusion to see what's going on here? How much room do I have if I do this and this? If I drew a line between the two. So by doing that, I'm at 0.391. So in this case, everyone, this is a good learning opportunity. I want to go machine this part. I, again, haven't looked at this part before. Not saying it couldn't be done with a 1/4" end mill. It definitely could. But it's a lot nicer to do it with a 3/8 end mill, just when it comes to the wall height, the amount of time it will take to machine, the finish we'll get. I would love to use a 3/8 end mill for this purpose. Okay. Now, looking at this model, I'm looking at, the different joints of this, and the only thing that really goes with this is this connecting rod, or not the connecting rod, the crankshaft. The crankshaft. Nothing touches the surface. So if I see that, I might be to my customer, hey, it looks like you have a non-critical surface on the inside here, and you have it designed to whatever the diameter of 0.59 something, right? Or bigger than that it was. I would ask my customer, say, hey, customer, is there any chance that we can shrink down this boss? Because if you shrink it down to this size, it will be a lot easier for me to make. And that would mean it would be, for one, it will give you a better finished part. And two, it'll cost you less because I can machine it faster with a bigger tool. Your customer would either say yes or no. Good news, guys, is I'm the customer. And I'm going to say, yes, Greg, go ahead and shrink down that boss to make it easier for you to machine. So how about this? The model that you guys are going to get, talking in future tense here, is going to be this new model. I'm going to save it right now, and this is the one that's going to be uploaded online. So from the beginning, your part is already going to be right. So you don't have to follow what I'm about to do. And what I'm going to do, guys, is I'm going to do a little cutaway. I'm going to go bring in the updated model. I'm going to redo all this stuff, and then you guys won't even see it. I'm just going to cut to the new model. Well, that didn't take too long. Let's get back into it with the 3/8 end mill with this OptiRough. Let's go into our parameters. We're going to update our model geometry, and we're going to triple click on this wall. Now, I'm going to tell you right off the bat that because this gap is just slightly bigger than 0.375, I'm assuming, especially when we're leaving 10,000 wall stock, that when we do our OptiRough, it's probably not fit into that gap, and that's fine. Okay, we'll deal with that when we get there. My boundary change should be exactly the same. Should work. I feel like it should be there. We'll see what it looks like. Okay, should be fine though. 12,200, that's fine. Everything else should be good. Our depth is different though, so let's go to our steep and shallow because this depth is different, and let's make sure that we reselect the bottom of that, or else it wouldn't cut all the way down. Everything else, our step down as 0.75 should work. We could hit OK, and we'll just see what it looks like and work from there. Okay, so like I assumed, it roughed out as much as it could at our bottom of our cut here, and then it stepped up to face off this wall, leaving 10 thou. As you can see, it tried to get its way in there, but it can't quite fit in there. So everyone, let's evaluate our options. First option is we can make a new stock model of what's left over after this and then use a 1/4 inch end mill to rough out the rest. Again, I don't like the 1/4 inch end mill. If I can avoid it, I'd like to avoid it. If I can't, then whatever, But for now, let's try to avoid it. The second thing I could do is I know my 3/8 inch end mill can fit in there. If I go back to my Fusion file, let's just remember what that looked like, right? Like what's this 0.391? So that should leave me. So let me write that down myself so I can remember. 391. Well, that gives me 10 thou and 6 thou, 16 thou to work with. Hopefully I did good mental math. That gives me about 8 thou on each side. 0.375 should work out. Let me just double check because I might use that number. 0.375 plus 0.016 is 391. Yep. So I have 8 thou on each side. So even if I did, I could probably get this to work, guys. I wonder. Let's go back to my MasterCAM. If I went to my parameters and I went to my stock to leave on walls, if I made this like 5 thou, it might fit. We could see. It still might not. Sometimes there's some other settings that also block it from machining too small, especially like the retracts and stuff like that. So I could make this 1 thou and really see what happens. And let's see if it like, I just want to show you guys what could happen. Remember that dynamic OptiRough is in its way, it likes room for one. But even if it did fit in there, which it didn't, it would do these tiny little cuts, zoom, 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 all the way through. I'll tell you guys, it takes lots of time. I would much rather just take an end mill and do a contour all the way around to rough out that material. No one said we can't do roughing with anything other than OptiRough. It's just OptiRough is the best option for most cases. As you can see, we are running into a little bit of an issue, and that is fine. Couple options. We could just do an area mill that might work, and leave a couple thou on the walls and floors instead of even doing an OptiRough. But how about let's just do this? We already machined out most of this material. Now let's just machine out the rest with this contour going through this slot. And we'll make sure to still leave material on the floors and walls. Now, if I'm doing this, I'm going to shoot to leave 8 thou on the floor or on the walls. So just so that this contour I'm doing doesn't also hit extra material from my leftover from my OptiRough. Let's go back to my OptiRough and let's change my wall stock. For you guys, it'd probably still be a 10 thou. Let's change it to 8 thou because when I do my contour, I'm going to strategically leave 8 thou on each wall. So that I just want to make my OptiRough match it so that, again, it doesn't, when it comes off around the back, it doesn't have to machine extra material as well. I'm going to add a contour here. Now, if your arrow, this little red arrow, wasn't beneath your OptiRough, then you can move it up and down using these guys here. Wherever that arrow is where the toolpath is going to be made. And all I should have to do is I'm going to tell my cutter, I should just be able to do a contour. I'm going to select this as my contour. Okay. I don't want it to cut exactly up to it because I don't want to finish it. This is still a roughing pass. You can't finish your cut until you've roughed out the majority of the material. So this is a roughing contour as opposed to a finishing contour, which you're typically used to. I'm going to use my 3/8 end mill. I'm going to set my spindle speed to 12,000 and about a 1 thou chip load for my finish, as I typically like to do. My plunge rate could be 100 because it's going to be plunging outside of my material. My cut parameters, we will set this to wear. We'll do 2D. This is where I'm going to leave 8 thou on my walls. Okay. My depth cut should be 0.75. That should be fine. I'm not going to do a yet. I'll come back with a finish later. Lead in, lead out. We don't need an overlap. We probably don't even need arcs just because it could just probably come straight in, and that should be good. And depth, we'll select the bottom of this as our depth. Let's just select our top of stock. Again, make sure these are all in absolute feed plane, 0.1, 0.11, only at start and end. Let's make sure coolant is on and our plane is set to G56, which it is. Hit OK. Okay, something didn't happen exactly the way I wanted it. You can see that my toolpath is below my surface. So something went wrong with my linking parameters. Maybe, that's my first guess. Okay, right here, breakthrough. Last time we did a contour, there's a breakthrough added on. So let's make sure to remove this breakthrough so that it cuts exactly where we want it. Breakthrough should only be on when we're cutting through the bottom of our part. So I should see my tool is leaving about the same material between this wall and this wall. Theoretically, based on my calculations, it should be 8 thou on each wall. So if we watch that, we can just select my stock model with these two operations. That should bring that stock model into my verification. Sometimes MasterCAM's weird how their stocks work. Oh yeah, see, so whenever you just select the one stock model and the operations, it overrides what your stock is for your verification simulation. I'll turn on my workpiece. I'll make my stock see-through so we can see what it looks like. Oh, actually, I don't. You can see right here, it's actually finishing the floor. Let's go back and let's turn on 8 thou on my floors or 10 thou to match my OptiRough. 8 thou on my walls, sorry, apologies, and 10 thou on the floors to match the OptiRough. Now let's watch it one more time, and we should see that we're finishing it yet. We did the first, you didn't really see the contour, but we did it strategically after that. After that first OptiRough, just so a lot of the material is gone. It's not gonna be too hard. Now, I could see there's a little bit of material being left over here on this corner. I thought it's weird how it's stepped up on this. What is that? Interesting. That's okay. In reality, guys, this is a very little amount of material. Even though we left 8 thou on this wall from here to here, this looks like a double, so 16 thou. It's still enough that it's not going to affect the tool for its finished cut. In an ideal world, we could try to update the toolpath so it also knocks off that a little bit as well. But this is good for me. I like it. See? Why is my toolpath doing that? What I'm looking at is how my tool is stepping up right here and cutting there, which I'm not sure why it would do that. Normally that means something's off. To get rid of this, I might just be able to increase my step up to 20%. No, still wants to cut that wall. It's very interesting. Why? It's not a bad thing, guys. It's not like it's the end of the world. It's just, it's not needed. So I'm just wondering why it's doing it. Mill vertical walls. I'm just gonna try something out here. No, that didn't work, so I'll turn that off. Step ups. Next closest, I just want to see. That didn't do anything unless it's still generating. I'll give it some time. Back out, let's go back in. Oh, I turned off step up by accident. That's why I wasn't doing anything. I'm gonna turn that back to depth. To be honest, guys, I'm just trying to figure out why my tool would think if it already cut this, why does it go up and think, oh yeah, I have to cut here too? You're supposed to cut up top, like that's correct. I don't know what that is. Maybe I'll update you guys if I figure it out. But for now, let's leave it like this. Okay, I don't like this. If I look at my tool when it comes down, I don't like how it plunges onto the material. Let's get my tool coming off from the side and then entering. We never want it, even if it's 10th thou, you're gonna be left with a little bit of a vibration mark there. So my lead in, lead out, let's set this to at least half the diameter, so 0.1875. Let's just do 0.2 inches. That should be enough. And we can go down, and that looks good. Okay, awesome. Let's move on. We can finish with we could see how this area mill turns out. We can see if it should be fine. It should be able to move around because the area mill, based on the way it works, it should be able to get into those gaps. So again, we just got to go into our geometry and we got to update it. So machining region is going to be this pocket. I'm just going to go around and select it one by one, I guess. Okay. I'm going to tell it that this line is an air region, so it knows that it's allowed to move outside of this and work from the outside. And I'm going to want to make sure that I add this inside boss as an avoidance so it doesn't cut into that. And that could preview our chain, which looks exactly like what we want. I have to update the depth, so it's probably going to regenerate because I hit yes by accident. But let's go to our linking parameters and let's just update our depth, the new depth. Everything else, though, should be good. Look at that. The area mill does a perfect job getting around that, machining the inside wall, machining the outside wall, and machining the rest here. I gotta tell you guys, area mill is one of my favorite tool paths, especially for finishing. Looking beautiful. Okay, now sometimes a lot of people miss this, and you guys will see something like this on your test where there's like a raised boss. A lot of people, for some reason, forget to also face down the top of this boss. Many ways we can go about doing this. We probably won't want to use a facing toolpath because the wall's on the outside, and also we probably just moving across and back isn't appropriate for this scenario. So what we could do is we can do either an area mill or a contour, and that should be able to either or. There's many different ways of making things. Even dynamic mill is a decent option, but let's just do a contour and as our face for this, just because that's what I feel like today. Let's select the outside of this line as our contour. It doesn't really matter what direction it is because I'm actually going to make this cut on the center of the tool. Now what I could do is I could just draw a circle for it to follow. in the center because I'm trying to get my center of my tool to be exactly above the center of this face all the way around as I cut. So I can either see outside and then strategically offset my tool inwards, or I could just draw a shape for it to follow exactly. So let's just do that because that's fun. Let's try something new. Let's hit a new level. And whenever I draw a wireframe, I just like make a new level. I like to call it wireframe just so I can get it out of the way when I don't want it. Let's do, well, let's go to our Fusion file. I just like measuring on Fusion a bit better. I'm going to take out my calculator here. I'm going to measure this diameter. This diameter is 0.594. Let's divide it or subtract it from the inside diameter, which is 0.438. And then to get the size of one of those thicknesses, I got to divide that value by 2. So it's 0.078. Actually, I could just take the multiply of that 0.156 and add it to, no, 0.156. Yes. Divided by 2 because I want it in the middle. Let's add 0.078 onto that diameter, 0.438, 516. I might be doing bad mental math right now. I'm going to do circle center point under my wireframe. And I want to grab this center point. If it doesn't let you grab it, you could always hold shift after you kind of out here, and it should let you grab that, but I have no problem grabbing that. Relative position, that's new. I've never seen that before. Enter. And 0.5. Yep, my math was right. It looks like 0.516. I'll just type it as a diameter. So you'll learn more and more about how we can use wireframe to help generate tool paths. I can go now into my geometry. I'm just going to select, I'm going to rechain. So right click and say rechain. Now, because this is wireframe, I actually have to select into my wireframe chaining and just select this. Again, doesn't really matter what direction it is. I'm just going to OK. And doesn't matter what side it is. Now I want the center of my tool cutting on that line. Typically a contour, our tool cuts on one side or the other. So what we're going to do is we're going to go to our cut parameters and let's change this compensation type to off. And that should allow our tool just to cut, actually the center of the tool will follow that line. We don't want to leave stock on the walls or the floors because we are finishing our part. We are going to be using, I might as well use our 3/8 end mill. 12,048 looks good, and we'll add a plunge rate of 100. We don't need depth cuts. Lead in, lead out, I would like to be turned on. So let's do like 0.2 again, at least for the diameter of the cutter, and we can see what that looks like. I haven't done all of my depths yet, so let's go fix that. 1 inch, 0.1, 0.1, top of stock is actually, well, it's this face right. Just grab something off that face, but it's actually technically 10th thou above that. So let's just add 0.01 to that face to really specify what my top of my stock is. And then I can just select my depth. No breakthrough. Planes should be G56. Coolant should be on. Let's see what that looks like. Okay. I don't like my entry and exit right now. We could take a look at why that is. I don't want my tool to drop on my part. I never like that. Even though it would work, it's not what I want. So let us, if I flip the side of the contour, it'll approach from the other side, which we'll do. So let's just exit out of this. Let's go to my geometry. You see how right now it says inside. Let's just say change side. That'll flip it to the outside. And I'll know right off the bat that I also have to shorten up my lead in and lead outs because it would probably crash into my walls. So Oh, unless we strategically positioned it. Let's leave it for now. Let's do, let me just double check that everything should be good. So let's regenerate this one. Now you can see that this is going to be crashing into my wall, right? On the way down, you don't want that. So let's go into my geometry and let's see if I can change my start point. Okay. New lesson for you guys, unless I could just say move dynamically. Oh yeah, right here. Let's just set it right about there. So I press move dynamic and I was able to move it there. Just approximately. Let's update this toolpath. And now we shouldn't be hitting. Beautiful. We can probably get rid of a little bit of the lead in, lead out. Let's get rid of the length here. Let's just do 0 and Z, just because that'll be nice. Just saves us a bit of time. I like it. Now it makes me want to, I just want to double check. Okay, this contour. So by accident, I guess I made this contour above my area mill, so it doesn't matter if it's before or after, to be honest, everyone. It's really up to you. I just want to make sure my area mill's at 0. Looks like it is. Let me just double check. Stock to leave on floors. Yep. Yep. Good. Okay. So that inside is now finished. Close these guys up. Okay, so we have some holes again. This time the holes are a little bit different. Unfortunately, I have not updated the dowel pin size on this model. I am going to cut away. And when I open this back up, you should see the dowel pins being the proper size. You know what? I'm gonna keep going. Yeah, I'm not gonna do that. Let's keep going. The holes don't, I could just change the drill size no matter what. It'll look bad. I apologize, guys. Again, you guys are kind of my guinea pigs, and I'm going to be updating this. The other part actually has 1/4 inch dowel pins, and those were updated from the current size. And I did not update this part before making this tutorial. We'll make sure our drawing, well, actually, let's see what I did on the drawing. So my drawing did not call out those holes. Let's add this. This should be, and that's why. Okay, I see. I messed up here. This was supposed to be here. That's why I thought it was good. Okay. 0.255 minus 0 plus 0.05. So looking at our 0.255 hole, we want to open this up to somewhere between 0.255 and 0.26. This is, if you look at the assembly, we can see that this is where a 1/4 inch dowel pin is going to go. They're not assembled actually into this model quite yet, but it is going to be a 1/4 inch dowel pin that was pressed into the engine 1 part. So what this is going to be, it's going to be a sliding fit on this side. That way we can take apart the parts, but the dowel pins are more just aligning the parts together. They would normally want to be a very, very close fit. For the purposes of this assignment, we're going to go for a decently close fit, but we're not going to get perfection because we do not have a proper reamer, which would be an oversized reamer. So something about 0.2525 to 0.255 reamer, which would give us a really, really nice sliding fit that would perfectly line up our parts. So that's why the tolerances are a little bit bigger. So we just want to find a drill that would fit somewhere between that. So anywhere from 0.255 to 0.26. If I open up my chart, sorry, my drill chart, I'm going to bring that over. We can see that a 0.257, which is 2 thou bigger than 0.25, is a letter F. That looks perfect to me because even if it drills a couple thou bigger, it'll still be within tolerance. So we're going to use a letter F drill on that hole. Now, we have 2 spot drills here. In our last part, we had a dowel pin right here, hole that we reamed, and we had our 10 dash or our quarter dash 20 tapped hole. Now, the tapped hole was from this side, it was blind, but now we have a counterbore coming from the back side of this part. So what we might want to do is, how about let's wait to make this hole that goes all the way through when we're on the back side. We can do the counterbore and the drilled hole all together. In my opinion, it just works a little bit better. We make sure that the counterbore and the hole align. So we really only need one of these drill counterbores. We can delete one out. So I'm just going to click on one, make sure there's only one check mark, and hit OK. For the other drill counterbore, I'm going to go to my geometries and I'm going to delete these 2 guys and I'm going to update it as this hole. I wish, try that. Whoa, 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 whoa. Didn't mean that, sorry. Let's try that again. This one and this one. Let's go into our parameters and we can tell that our depth calculator, finish diameter, well, we can, it should be about 10 thou chamfer. So let's do 0.257, which is the size of our drill, plus 10 thou chamfer on each side, plus 20 thou, and we'll hit enter. And that will give us a nice chamfer. Now, obviously, like I said, I messed up the hole size on this part. It's not updated. So when we drill this out, it might look like, it is going to look like it's drilling much bigger than what it's supposed to, but we are going to just trust our drill sizes that it is correct. The depth, however, doesn't really matter. We'll make it go all the way down to the bottom of this pocket here. Like so. No. It's making it hard for me to grab. Let's try it again. It's in my way. Why is it not letting me select the bottom here? It's kind of weird. If I do, come on. Makes me want to check out my planes. G56. It's really weird. Sorry guys. 3/8 spot drill. I apologize. Okay, so there's my spot drill. We're going to go and we could override this chip break. Inside of this chip break, we can just change our tool over. So we're going to right click and say select library tool, and we'll find our drills. Okay. And let's find that 0.257. So actually, let's go ahead and equals and say 0.257. Should be a letter F drill. Hit OK. 6,000, 0.0025 about chip load, like we talked about in engine 1, gives us a feed rate about 30. It's good. cut parameters. Let's make our PEX. Yeah, 0.25 is good for PEX. Chip break is nice. Let's do our linking parameters. Top of stock is here. Our depth, let's set our depth to be the bottom of this pocket, which for some reason I'm having a really hard time with selecting. Oh, I saw it right there. Bam. Minus 0.1875. We'll make sure we turn on tip comp. And let's do 0. For amount, we don't want it to break through much. We just want the shoulder of the drill to go to the bottom there. It does show a flat bottomed hole, but obviously it will have to be a drilled hole. Make sure the coolant is on. And then lastly, we need to change the geometry over to these holes. So right here and right here. Hit OK. Regenerate. Yes. We should see our drill goes nice and down. Perfect. Looking good. Okay, so the other hole we're going to do from the other side. So for now, that is all for this operation. These other ones are not needed. We could try to save them if we wanted to, but let's just delete those out. And like we could save them for the next op, but let's just start from the ground up on the last op. Making sure I have everything machined, we could update our stock model. Let's see what it looks like. Now, because I could see there's a face on top of here still, because we added a contour, so we should go into the stock model and update its reference or source operations to also include those two contours that we did there and there. And that is much better, I believe. While we're at it, we could make this hole that goes through the center of the part, or we could wait for the last op. But since we made this one on this side, maybe we should go through. Maybe we should go through there. I apologize for missing that. I was focused on changing over all the tool paths. Let's make this hole go all the way through. This bore on the inside. This radius looks good, or the circle, everything else looks good. So let's just fix this up. So let's do, maybe we might want to position this before we do, like in our roughing operation still. So after maybe that and the roughing op, let's add one last rough here. And what we'll do is this could be a circle mill. I like circle mills for circular pockets, and we'll select the inside of that. And we're going to go in here and go to our tool. We'll select our 3/8 end mill. We'll do our speeds as 12,000. Since it's roughing, we can do about a 3,000 chip load or 3.7 thou chip load. I hit OK by accident. Don't do that. Let's go back in there. Let's go stock. Leave on walls. We should be able to do a rough and a finish all in one with the circle mill. So let's set it to 0 and 0. With my roughing, I'm going to set my step over to be about 33%. Minimum radius, I like to always be 5, and 45 is a good number, especially because it's kind of tight for this 3/8 end mill, but it should work. Finishing, let's turn on finishing, and we'll do one finish cut, and we'll leave, because we're so tight in there, we might want to leave 5 thou for finishing, and that should be good. Depth cuts, we'll see if we need a depth cut in a second, so let's go and turn this stuff on. 1 inch. Let's set everything to absolute right off the bat. 1 inch, 0.1. Top of stock is 0, and the depth is going to, actually no, the top of stock isn't 0. The top of stock is right here. Why? I've been having lots of issues actually. If I hold shift, I don't know why it's selecting up there, but if I hold shift, it seems to let me select that specific point. It's really weird why it's doing it like that. I am not sure what's on my program that's making it not snap to the hole. This is new for me. That looks fine. We will do a breakthrough of 50 thou. Everything should look good, except coolant might have to be turned on. We'll add that. And nothing shows up. If something doesn't show up, it means the tool might be having a hard time in doing the tool path itself. Normally we'd get alarms if MasterCAM was nice to us, but sometimes it doesn't like us and it doesn't give us alarms. There is this helical entry, and this is my assumption of what's going on. It says if helix fails, skip. So it just skips it. I'm guessing if I turn on plunge, it's probably just going to plunge and then do the cut. Yep. Oosh, this is pretty tight for a 3/8 end mill, especially if you're not helixing down. A couple options: we could switch to a 1/4" end mill. We can machine or we can drill a 3/8 hole. And then open it up to the final diameter, which might be the best bet, to be honest. We already have a spot drill in here. We would just have to add another drill into our mix. Normally you want to helix in, but if you can't, like we might be able to lower the helix down to, like if I go 1%, it works, but this is going to take forever. Remember, there's stock in here. That'll take a very long time. So let's do this. Let's blow through this hole. Let's make a hole that goes through this part. Now I want to warn you though. See this little nub right here left over? Actually, we should be able to work with that. We should be able to start a spot on the top of that and then drill through. So let's keep this circle mill, but before the circle mill, we're gonna have to do some other stuff. So maybe we'll put I'd like the contour being after, but it might be nice to position my 3/8 end mill. 3/8 end mills all at the same time. I'm trying to line up my tools so that I don't keep switching tools too much. So let me just think. I could do I could do this right off the bat, and then I can, I don't know, rough it out. I feel like I'm gonna have to I will have to change my spot drill in and then back in after. Unless do OptiRough, contour, circle mill, contour with the 3/8 end mill, 3/8 end mill, 3/8 end mill. This would be done 3/8 end mill. Move it up. This would be done. Move it up. If you just drag it over and say move it up, you can change move it before or after, you can change the order. This circle mill would be here. But no matter what before that, I'm gonna have to put a spot drill back in because the spot drill has to be after the OptiRough. So no matter what, I'm gonna be putting my spot drill back in. So it doesn't matter when I do it. Let's do it early on in the rough. So after the roughing, a little bit of wasted time, that's fine. We'll do it after that. So contour, move before. So OptiRough, contour, and then we'll put this tool path. Doesn't really matter. Finish. I might just want this one to be before, because then it will make a burr, and then the top will be machined away, which will be nice. Okay, so let's add some tool paths here. I'm going to add a drilling tool path, and I'm going to select this as my drilling tool path. My tool is going to be my 3/8 spot drill. By the way, I'm going to come and renumber all my tools afterwards because we started with a bunch of tools in here. For my spot drill, let's do 8,025. And we'll do just a drill counter bore. We'll go linking parameters. Top of stock is going to be about 10th thou above that. So I'm going to click on, what is going on with you today? I'm holding shift. It seems to be getting working through that. I'm not sure why. Yeah, it's very weird. My depth is going to be that, or 50 thou below that. So top of stock is this plus 10 thou, because we left 10 thou on the top on our OptiRough. Then my depth, I'm going to want to start with this value. And I'm going to want to subtract another, let's say 50 thou off of that. That'll drill something slightly below right there. My retract could actually be, I can move this below just to save some time. My clearance is still 1 inch. And my retract could just be plus 0.1 above that. Hit OK. So now my tool will wrap it in and it doesn't spend all the time feeding in to that point there. And then we get ourselves a spot, but it looks like it's going pretty deep, which would mean that my tip comp is on. So let's turn that off. And there we go. There, that will work. Then we'll drill out a hole with a 3/8 drill. That way my 3/8 end mill can fit through that. So tool is going to be we're going to select a new tool, filter for a 0.375 inch drill. Hit OK. Okay, we'll do about 6,000 RPM on this guy. And we'll set this to 0.0037. Yeah, I know. Cut parameters, we will probably want to peck it with 0.375 inch pecks. Our top of stock is once again right here, but apparently I have to hold shift to do this weird thing. I don't know why that is. My depth will be right here. I need to figure out what the heck is going on. That's not letting me select my part properly. Hopefully you guys don't have the same issue. It's right there. Tip comp on with a little bit of a breakthrough. Let's do 50 thou. Planes, coolant, make sure it's on. Hit OK. Now I have a drilled hole. And then we should be able to put our circle mill. So finish, then our circle mill. And in our circle mill, we don't want it to helix anymore because we basically essentially made a helix, like the entry by drilling it out. So let's just go to roughing and let's turn off helical entry. We probably don't even need a roughing. Let's just do finishing because I mean it's so cutting such little amount anyways. And we will want to, there's a box I'm looking for here. Add keep tool down. We should actually add a depth cut of 0.375 just in case it's any more than that. Might be nice to, nah, it could handle it. But I am looking for this transition. So if you don't see this, make sure you hit the drop down under finishing, go to transitions and turn on lead in, lead out. We want our tool to start at center and end at center. That way it feeds straight in the middle of the drilled hole and then straight back out over the drilled hole. There we go. Beautiful. Okay, we're back on track here. So circle mill, that's done. We drill out that hole, we drill it out. Let's update our stock model one more time. Including all of our Op3 stuff. And that's looking pretty great. I just don't know why I'm seeing a little bit of stock on this wall. Maybe we should just verify this and see what's going on. See if there's just to verify. Nope, it looks good in my model. So it was just a rendering issue. Everything looks good, nice and shiny. And we could hit subtract out of that. Any more? Okay. Well, guys, there we go. We updated it. let's finish this part off. Let's flip this over and get it done with. So let's flip it. And I like the 1032 taps facing towards me. I think that's a good rule. So we'll face them towards again. And we just got to make a new plane. Before we do that, might as well make a new op at the same time. So I'm going to go right up here, right click my machine group and select new toolpath group and set this as my op 4. Apology. Hit enter. And let's turn off my stock model. Let's do another plane. Select my plane as something like right here. Minus 90. What the heck? Minus 90. Enter. And flip it 80. Hit. And then just, I want to move it so that it's at the side of my X. So just grab that and grab any feature on the side here. Bam. Now, because I believe that our op3 and op4 will actually use, we need a different plane, I guess, but actually, do we? For now, we'll call this G57, but I believe our X will be the same. Our Z, because it's just the thickness of the part, the thickness doesn't change. The Z should be the same, and the Y should be the same. So when we set this up on the machine, we actually might not need to make this G57. We'll probably just make this the same as G56. You just flip it and it's just G56. Saves us from having to set up G57. So if it's G56, we'll do 0, 56, sorry, 54, 55, 56. Okay, hit OK. Hit equals. Let's go to toolpaths. And let's finish this, everyone. Let's typically, especially because we have this radius here, we could spot drill and start drilling, but this radius might actually mess with our drill. Our drill might veer off to the left and to the right on this side. So let's just start by counterboring this out. I typically like to drill first, but because of the radius, I think we should drill or counterbore it out first. If you drill it out first, you can lower your tool in the center of the drill, kind of how we did this through pocket there. That should be good. Okay, so let's do some circle mills. Tool paths. Let's do 2 circle mills, 1 circle mill here. 1 circle mill here. And let's select, well, I can't tell, well, I think that the counter bore is 0.45, so we can probably get away with a 3/8 end mill. I'd like to. 12,000. And our feed rate is going to be, well, about 144 might be fast for this. Let's do 100 inches per minute. If I haven't done this before in that last, I could go back to the last circle mill and change this to where. I should have done that. Roughing, we'll try roughing out. We'll do a helical entry. Let's try a 5% radius and see if that's enough. And if we can finish at the same time, we might as well. Start at, say, I mean, that doesn't matter too much. Depth cuts, we shouldn't need depth cuts. Linking parameters, our top of stock should be 0 in this case. Our depth will be the depth of this pocket, which if you would just hold shift, you might be able to grab something at the bottom. Minus 0.25. Coolant on. Okay, so it's not horrible. We do have some wasted time here, so let's see how we can make this a bit better. I wonder if 10%, let's just try that. No, see how it didn't work, so let's lower it down until it works. You want to have the biggest helix possible. Okay, 6%. Not lots. XY clearance 0.01. Well, why don't we just make it 0.005? That'll allow us to have a bigger helix. That's how much wall it's seaming on the helix, so 5 thou is fine. Z clearance is where the helix starts, so why don't we just do something like 20 thou, and that should lower down the start of the helix. Saves time. And our plunge angle, typically anywhere between 3 and 5. 5 is probably a lot. Let's try it out. Actually, for aluminum, we might be safe there. It shouldn't take too long to get on all the way down. We will want to make sure our plunge rate, since we're plunging material, let's make it half the feed rate, which is 50. And that should be good. Bam. Okay. Let's do a spot drill. If I want, I could just reselect an old spot drill, but let's just do a drill. And we'll do you and you. And tool is a 3/8 spot drill, going about 8,025 or 30, something like that. Cut parameters is going to be drill counter bore. Linking parameters is top of stock is going to be this bottom face. The depth is going to be another 50 thou on top of that. We don't want tip comp on. We want turn coolant on, and we could hit go. And my plane is something's off. Apologies, we never updated our retract. Looks like our retract should be above the part. So let's bring that up to 0.1. That would crash. There's the crash right there. Have you ever seen one? There we go. Much better. Because that spot drill looks like it goes in there nice. And we just got to do the drill. It's not just because I could just copy paste if I want, and I'll just update the drill size to, I believe, a letter F drill. The letter F was going to be the clearance or like the sliding fit for our dowel pins. But also, if you look up a tap drill chart, you can see that it is recommended for a 1/4 20 bolt, which the thread that is going through this is a 1/4 20 bolt. A recommended clearance hole drill is a letter F drill, or 0.257, for a nice close fit. So let's use that, even if the drawing called for a 0.26. Let's make it even better. Letter F drill. We can start at 8,000. Let's make the chip load about the diameter, 0.0025. That's good. We'll do cut parameters, and we will make sure to do peck or chip break. And we'll set that to 0.25 about, which is the diameter of the cutter close to. Our top of stock is minus 0.25. Our depth will be the bottom of the part. There we go. And we will want tip comp on, 50 thou, breakthrough as well. Coolant should be on, and we hit go. And that should do it for us. Let me walk through our program here. We face, we do an OptiRough, we do our contour, we do our spot drill, drill and tap of our 3/8 tap. I apologize if you hear some background noise, my printer's going. We're facing the back side of the part, flipping to the front side, roughing out this step. We are then contouring to rough it out. Then we're spot drilling, then drilling, area mill finish, contour the top face as a finish, contour the bore as a finish. And I forgot to also go back to that original circle mill and change that so that it's cutting on where. I could double check my other tools, my contours I made, see if those were automatically set to where they should be, because before, oh, this one's off, sorry. I should know that, but this guy that I made should hopefully be, this one doesn't have to be set to wear, but that's fine if it is. It's more than just the finishing passes that we want to be able to have wear accommodation if we need. Everything looks good, so let's continue on. So circle mill, drill, drill. That should be good. Our stock model, circle mill from the backside, drill, spot drill, drill. We can regenerate all just this last stock model because it looks like it's off. And there we go. Now before the end of this tutorial, let's go back and let's clean up some stuff here. If we go to our tools, we can see exactly what tools are no longer being used because they don't have check marks on them anymore. So if I just hold shift, and I can just actually, well, one by one, I guess I got to click on it and press delete, 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 delete. So we still have tool 1, face mill, tool 2, 3, spot drill, 3, 16, 4, 1032, 5 is our 3/8. We'll make 6 our 1/2 inch end mill. We will make 7 our letter drill. And we'll make 8 our 3/8 drill. Sorry, number 8 drill. What am I talking about here? Okay, before you exit this, you want to make sure to reselect what tool is supposed to be for this tool path. So the face mill, hit OK. What I will do now is now it wants me to update all my stock models, so just regenerate all dirty. Yes. Oh, I hate when it does this. This is so. I don't like this overwrite feature. I want to change this, maybe just automatically save every few minutes instead of after every toolpath, because this gets kind of annoying. Okay, you done? Okay, awesome. Let's do one last thing where we just simulate the whole thing, and then we can develop our setup sheet, which you don't have to do for the purpose of this for marks. You just want to know how to set these up. So when we go to lab, you know what's going on. Nice and shimmery, except we may have weird borders, which is fine. Our counter bore doesn't look that good, actually. Are we cutting too far in or what? Where's our counter bore? Looks like it's cutting too deep to me. Yep. Let's fix that. And let's change that to probably not have breakthrough, I'd assume. Much better. And if we really wanted, we could just simulate it one more time just to be happy and see the final part. Looks good. The bottom face is nice now. The walls look red to me, but they kind of have a shimmering. Sometimes holes don't look the best. I could just double check on my circle mill that there's nothing left on the walls or floors, or I mean on the walls. Yeah, it should be good. Okay, there we go. Ta-da. Let's close all these up, save it, and let's open up our tools and let's start building our setup sheet. Now, because it's very similar to engine 1, it should be pretty easy to just change this over to engine 3. Let's open up our engine 1 job sheet. Let's open it up and let's just say file, save as. Let's change this to engine 3, and I'm just going to change my save location to ENG-003. What did I just replace? Weird. Okay. Let's do this. Let's do this. Okay, tool 1. The stock should be the same. Inch and a half face mill, 3/8 spot drill. Number 16, 1032, 3/8. And then this is different. So after our 3/8 end mill, which is tool number 5, which doesn't 1.5 out Auto holder, does that apply? Let's do this. Probably not. It's not doing that big cut, so we can probably update that. Uh-oh. Why am I crashing out here? MasterCAM. My 3/8 spot or end mill is just used for this pocket, which is only 0.6875. So that doesn't matter, but our 3/8 end mill will need at least 0.37 or 0.75 of flutes. So that will stay. This doesn't matter. Let's turn my program back on. This. Let's see our tools again. Tool 6 is going to be our 1/2 inch end mill. This end mill is the one that should have, well, actually, I'm just going to copy this to here. I'm just going to change it to 1/2 inch. .5 flute min. Tool 7 is an F drill, which is a 0.257. Tool number 8 is a 3/8 drill. There we go. The op1 remains, op2 remains, op3, and I'm going to say /op4. Now, if you're curious on why these are, you can ask me, but they are the same. We're going to call this, I like to add this in G56, just to G55 and G54, op3, and then op4 should be rotate part so that radii face, no, we're not gonna, so radii face upward. And 10-32 holes face towards you. Now, if we need a little bit more room, perhaps we can cut some, either shrink it down or just make another little thing. Right here. That'll work. I'm sure we can read that. Might be small. We'll see. I could change it later after this. Update some formatting to make a little bit more room for that. Other than that, things look good. Change the name to ENG-003. Block right hand. And we are done. Save. Except we should also update some of our tolerances here, but we'll do this in class. So I'm just going to delete this out for now, but you guys could see why we would have that, right? So for today, we'll leave it there. But in the future, we might want to fill that out for ones to measure. So let's hit, let's end it there, guys. Hopefully this part does you well. Shouldn't be too bad. a little bit of knowing how to update your parts, which is a really good thing to know, because honestly, whenever I'm able to, I try to just use old programs and just update the toolpath so that I'm not, resetting all the parameters. It makes things really easy. And we know that a lot of these toolpaths already work, so just by applying it to this part, we shouldn't have to have too much troubles in the lab class. So we will see you in the next part.